Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering a question from the October-November 2021 Cambridge 9709 syllabus. This is paper 1, the pure mathematics paper, variant 3. And we have a question dealing with equations of circles, which is a new topic in the syllabus that started in 2020. So here we have the line y equals 2x plus 5 intersects the circle with the equation x squared plus y squared equals 20 at A and B. Find the coordinates of A and B and insert form, and hence find the exact length of the chord AB. So some mistakes that people make in a question like this, especially in the exams, is they don't read the question properly. So a lot of students would stop here. They will read this, and the rest of the question they won't read. Okay, they wouldn't read the rest of the question. Okay, but they'll say they'll read find the coordinates of A and B. So what they'll end up doing is writing the answer, okay, not insert form. And secondly, they wouldn't go on to find the length of the chord AB. So these things would cause lots of marks to be lost. So make sure you take a few seconds to read the question carefully and underline. I don't think you can use the highlighter in the exam, but underline some key points. So find the coordinates of A and B, insert form. So that's in your head now. So when you answer the question, you know that you're not going to round it to 3SF. You're going to leave it in exact form. And then find the exact length of the chord AB. All right, so you know that there's not just that, there's something else to do. Sometimes the question is split up into parts. A, part 1, find the length of AB. And part 2, find the coordinates of AB. In part B, find the length of AB. But here, it's like in one sentence, 2 parts. So don't just stop here. So some people find the coordinates of A and B and they stop. So be very careful in the exam not to, just throw marks away. So this is actually quite a straightforward question in terms of, it's even IG level, this first part, where you have to find where these two functions intersect. So you have y equals 2x plus 5 and x squared plus y squared equals 20. To find the way they intersect, the way I like to think about it is you have to substitute one of the equations into the other. Okay, so using substitution, I can say that this y is equal to 2x plus 5. So I can replace this y here. This y can be replaced with this 2x plus 5. So I can rewrite this equation as x squared plus, instead of y squared, I'm going to write 2x plus 5 all squared. That takes place of the y that was there, equals 20. Now, when I rearrange and solve this equation, I'll find the x coordinates of A and B. Okay, they didn't say which is which, so it doesn't matter. All right, so one of them would be A, the other one would be B. Then we'd have to find the y coordinates as well. It says coordinates means x and y coordinates in coordinate form. So that's another thing we have to remember, not to just stop with the x coordinates. So now we need to expand the brackets. We have x squared plus, that's going to give you, when you expand a square bracket, you square the first term. So remember to square both the number and the letter. So 4x squared. Then you multiply these together and double it. So that's going to be plus 10x times 2, which is 20x. And then you square the last term. That's going to give you 25. And that's equal to 20. Now I'm going to simplify. So I have 5x squared plus 20x. And I'm going to have 25 minus 20, which is going to be plus 5 equals 0. And then to make it easier for me to solve this equation, I see there's a common factor of 5 throughout every term. If I divide the whole of this equation by 5, I'm left with x squared plus 4x plus 1 equals 0. Okay, x squared plus 4x plus 1 equals 0. Now I can solve this equation. Now I know I'm not going to be able to factorize this because it says find the coordinates of A and B in third form. So of course this is going to be an answer which is going to be in third form, so it cannot be factorized. So I can either use the formula or I can complete the square. Okay, but what you can't do is you can't just put it in your calculator and write x equals and x equals. You will definitely lose marks. You will definitely lose marks for that, no doubt about it. So don't be lazy. Right? The examiner's reports very, very clearly state that. Okay, that if you don't show that either you factorized, completed the square, or used the formula, you will lose marks. So I kind of stress this to students because a lot of students have become very lazy with these kind of things. Very, very important. Okay, now I'm going to do this by completing the square because it seems pretty easy to do that anyway. you could also use the formula. So to complete the square, what I like to do is I like to isolate the x squared and x term on their own. So I'm going to subtract 1 from both sides. Then I'm going to write my bracket, which is squared. I'm going to have x, the square root of this, plus, because there's a plus between them. I'm going to take this coefficient of x and write the coefficient, but half of it. So x plus 2 squared. Now, if I were to expand this, I would have got x squared plus 4x, but then I'll get plus 4. I don't want that plus 4, so I'm going to take away 4 from that, and then I'm going to end up with this. This is actually the same now exactly as that. Now to solve this, I want to isolate the square bracket, so I'll have x plus 2 squared. I'm going to add 4 to both sides. Minus 1 plus 4 is 3. And then the next step is for me to, I know x plus 2 squared equals 3. That means x plus 2 is either the positive or negative square root of 3. Don't forget, it could either be positive or negative, otherwise you'll lose one of your solutions. So therefore, x is equal to minus 2 plus or minus root 3. We found basically the x coordinates of the points A and B. Okay, which one is which we don't know actually, but now we have to find the y coordinates. So we're going to use this equation y equals 2x plus 5, which is of course the easier one to use. So we're going to take y equals 2x plus 5. Yep. Y equals 2x plus 5. And we know when x is equal to minus 2 plus root 3, okay, then we can say y is equal to 2 times minus 2 plus root 3. So this is 2 times x plus 5. So y is equal to, that's 2 times the minus 2, which is minus 4 plus 2 times root 3, which is 2 root 3 plus 5. So 5 minus 4 is 1. So we end up with 1 plus 2 root 3. So that's one pair of values. X is minus 2 plus root 3, and y is 1 plus 2 root 3. So let's say we'll call that A. Doesn't matter which is which. And then you have x equals minus 2 minus root 3. That's the other value of x, in which case y is going to be 2 times minus 2 minus root 3 plus 5. Y equals 2x plus 5, which equals minus 4 minus 2 root 3 plus 5, which will give us 1 minus 2 root 3. Okay, so then we have our other coordinate, which is the x coordinate being, let's call it b, the x coordinate being minus 2 minus root 3, and the y coordinate being 1 minus 2 root 3. So those are the values of the points at which the circle and the line meet. So now that's the end of the first part of the question, which is find the coordinates of A and B. Now don't forget there's another part which is, and hence find the exact length of the chord AB. Okay, so what we found is the coordinates of the points. Now we've got to find the length of AB. Now the length of a line segment is given by Pythagoras' theorem basically, and the formula for that is, you know, the magnitude of the line between A and B is the square root of xa minus xb squared plus ya minus yb squared. So we got to be careful because of all these square roots and stuff we're dealing with this and the minus sign. So let's just do this carefully. You have to be very careful in this question not to make silly mistakes. So you have xa minus xb. So you have minus 2 plus root 3. Okay, minus 2 minus root 3. And all of that has to be squared, plus, and then you're going to have 1 plus 2 root 3, that's ya, minus, I'll put this in brackets, 1 minus 2 root 3, and all of that has to be squared. Be careful when you do this because of the minus sign, so put the second part in brackets there. Now, what we have to do is basically find what this is. So you have minus 2 minus minus 2, that's minus 2 plus 2. Okay, so what's going to happen there is a minus 2 and the plus 2 is going to give you 0. And you have root 3 minus minus root 3, which is going to be root 3 plus root 3, which is 2 root 3. Then you're going to have to add to that this. So you have 1 minus 1, which is 0. And now you have 2 root 3 minus 2 root 3, which is going to be 2 root 3 plus 2 root 3, which is 4 root 3. So that has to be squared. That has to be squared. So when you square this, you're going to end up with the square root of, now 2 root 3 squared, that's 2 squared is 4, root 3 squared is 3. So it's 4 root 3 plus, and 4 squared is 16, and root 3 squared is 3. So you have 4 times 3 plus 16 times 3, which is 12 plus 48, which is going to give you the square root of 60. Okay, the square root of 60, and that's the exact length. If we want to write this in simplified surd form, we could do. Normally, it's better to do that. Are there any perfect squares? I think there is. 4 times 15, so you're going to have, this is like the square root of 4 times the square root of 15, which is 2 root 15. You can verify that if you want to using your calculator. You have 2 root 15. That gives you the same as root 60. That's right, 2 root 15 is root 60. So there we have, this is the length of the line segment AB. The length of the line AB is 2 root 15 or root 60. Better to write it in simplified surd form. And there we have the answer to this question. So be careful, 2 things in this question that we have to be careful about. Answers in exact form, and don't forget there's a part that's asking us to find the length of the chord AB. Okay, so that's something important for us to realize. So that completes part A. Now to part B. It says, a straight line through the point 10, 0 with gradient m is a tangent to the circle. Find the 2 possible values of m. Now there are 2 ways to answer this question. One is like a visual way where you can avoid a lot of algebra, which I personally would, in this particular case, would probably prefer doing. And the other one is a purely algebraic way. But just to give you an idea of what's happening, just so that we can get, picture what's happening. Again, I'm going to draw this circle. Okay, so I'll draw the circle with center O. Okay, now there's a point 10, 0, which is somewhere out here, 10, 0. And there's a line that passes through the point 10, 0, and it has a gradient m. And there's 2 possible ways that this line could be, such as a tangent to the circle. One would be there, and the other one would be there. So those are the 2 possible lines which go through this point 10 and are tangent to the circle. So there's 2 possible values of m. There's be for one for this and one for that. Now I'm going to draw this. I'm going to do the algebraic method first, and then I'm going to show you how to use this diagram to use a very just a visual kind of graphical method of doing it. Okay, which will be, I think, easier. But I'll show you the standard way which most people would answer this question. So we want to find where the line which passes through the point 10, 0, it's a straight line, which has a gradient of m, is a tangent to this circle. All right, so when something's a tangent to the circle, it doesn't intersect the circle, but it touches the circle at one point, passes by the circle without cutting through it. Okay, so a tangent to a circle, if you have a line which is a tangent to a circle, at the point where it's a tangent to the circle here, I mean, basically, if you try to find where this line and this circle intersect, you'd only get one solution. You'd only get one solution where this line and this circle intersect. Okay, so if you have one line and one circle, and the line is a tangent to the circle, there'll be one place where they intersect. Right, so we know already the equation of the circle is x squared plus y squared equals 20. All right, that's what we know. And what we need to do is find an expression for the equation of the straight line that we are seeing when it intersects this circle, where is a tangent to this circle. So we know the equation of a straight line is given by y minus y1 equals m times x minus x1. That's my preferred method of doing this, but you can do it another way. And we know that the line that we want goes through the point 10, 0, and it has a gradient of m. We could say y minus the y value of the point 0 equals m, which is m, which we have to find, times x minus the x coordinate of that point, which is, x minus 10. X minus the x coordinate of the point, which is 10. So you end up with y equals m times x minus 10. I'm going to leave it like that for now because it makes it easier when I'm considering what I'm going to do next. I'll leave it like that for now. But we could also do this by using y equals mx plus c. So we can say that here y is 0, and we want to find m. So you got 10m, mx plus 10. You have mx plus c. Sorry. What am I doing? What you'd have here would be y equals, so you're going to have y is going to be 0, m is going to be m, x is going to be 10 plus c. All right, so you end up with 10m plus c equals 0. So you can say c equals minus 10m. So you end up with y equals m times x minus 10m, which is exactly the same as we get there. Okay, m times x minus 10m. I mean, I prefer this to be honest, but that's what most students at this stage would probably use. So y equals mx plus c, y is 0, m is m, x is 10, 10m plus c equals 0. So c is equal to minus 10m. So then you can put it in here, y equals mx minus 10m. Okay. Now, I'll get rid of this part for now because of the space. So we know what the equation of this line is. And again, to know when these two functions intersect, we can use the same method that we used. We can replace the y with m times 10, x minus 10. So x squared plus, then I'm going to put m times x minus 10 squared. So I've replaced the y with m times x minus 10, and that's equal to 20. I'm going to try to simplify this now. I have x squared plus, if I square this, I'm going to get m squared. If I square this, I'm going to get x squared minus 20x plus 100. Okay, and that's equal to 20. So now I'm going to try to simplify this and make an equation like we did before, but this equation is going to have m's and x's in it as well. So you have x squared plus, and this gives you m squared times x squared. Okay, this gives you m squared plus x squared times x squared. Then you're going to have minus 20 m squared x. And you're going to have plus 100 m squared equals 20. So if you simplify this, you're going to have here if you simplify this, this is going to be basically what I'm going to do now is I'm going to write the x squared term with like factorize so I can have coefficients. So x squared times 1 plus m squared. This is just minus 20 m squared x, and that's plus 100 m squared. I'm going to take away 20, minus 20 equals 0, to make it say equals 0. So now it's basically, if you think about it, this is like your a. 1 plus m squared is your a. You got minus 20 m squared x, so 20 m squared is your b, plus, and you got 100. Let me just factorize this as well. So you're going to have 20 times 5m squared minus 1. This is like your c. So you can say, if I'm trying to now solve this by using the quadratic formula, or no, I'm not going to solve it by, what I'm going to do is this. I know that this is a tangent to this circle. It's a tangent to this circle. So that means it's going to touch it only in one place. That means when I solve this equation, I'm going to get one solution. If I solve this equation, I'm going to get one solution. That means that b squared minus 4ac has to equal 0. Okay, when there's one solution, when something's a tangent to something, then there's only one solution. When you equate there, or you substitute one equation to the other, then the discriminant has to equal 0. Okay, why? Because it's a tangent to the circle. Okay, only one place where it's going to intersect, it's going to touch. All right, so here a is 1 plus m squared, and b is minus 20m squared, and c is 20 times 5m squared minus 1. So if I put that into this formula here, you're going to have minus 20 m squared minus 4 times a, which is 1 plus m squared times, in fact, what I'm going to do is I'll write this m squared plus 1. I think that'll be easier. 1 plus m squared, which is the same as m squared plus 1, times 20. Put it like this, so I'm confused. Okay, times 20, 5m squared minus 1. Okay, so I know that that has to equal 0, okay, as there's a tangent. As is the tangent, I'll just put that. Okay, so this is going to give me 20 squared, which is 400. Positive 400 m squared, n to the power 4, sorry. Minus, and this is going to give you 80 times, I've just multiplied the minus 4 by the 20, and then I'm going to expand this bracket. So m squared times 5m squared is 5m to the power 4 minus m squared plus 5m squared minus 1 equals 0. Okay. And now what I'm going to do is I'm going to expand this bracket. So 400 m to the power 4 minus another 400 m to the power 4 plus 80 m squared minus 400 m squared. In fact, I could have simplified this right away. Okay, but no problem. And that would be plus 80 equals 0, because this would give me 4m squared, which is going to give me negative 320 m squared when I've multiplied by the minus 80. So anyway, these two cancel out. I'm left with here minus 320 m squared plus 80 equals 0. So I can solve this quite easily. I'll end up with 32 m squared equals 80. They'll both be negative, so it can be positive. Divide both sides by that's supposed to be 320. I wrote 32. Sorry about that. Be careful. I said 800 minus 400 is negative 320 m squared. So you end up with negative m squared, negative 320 m squared, or 320 m squared, sorry, is equal to 80. So therefore we can say m squared equals 80 over 320, which is equal to 1 over 4. So that means m, there's two possible values of m. You're going to have plus or minus a half. Okay, so m could be a half, or m could be negative a half. Those are two possible values for lines that could be, for gradients of lines that could be tangent to the circle if they pass through the point 10, 0. Okay, so that's the answer to this question using a very algebraic technique. Okay, now the final way of solving the second way of solving this question, which is a more visual type of way, and I think it's a bit shorter as well, really requires you to make a little sketch. And making a sketch of circles questions is always a good idea. It will always sometimes gives you a nice, quicker way of doing things, and sometimes it gives you, sometimes it's necessary for you to understand what to do. So here we have the circle. We know that this circle has a center, the origin, and we know the radius of the circle is the square root of 20, which is root 4 times root 5, which is 5 times root 2. Okay, so the radius is 5 times root 2, root 20. Okay, so if we draw a circle with center as the origin, like this, okay, then the point 10, 0 is going to be on the x-axis somewhere over here. Okay, now from that point to the circle, we're going to have a tangent. And there's another possible place where you could have a tangent also coming from that same point. And those are the two lines that are possible, which will have the gradients, the two possible gradients, which we know now are half and minus a half. We're going to show it from this now. So what we can do here is we can understand a few things. Firstly, if I was to carry on here and just say, okay, I know that if I join the center of the circle to the place where the tangent hits the circle, you have a right angle. The same will be down here. And I know that the radius, this is the radius of the circle, which is root 20, which is 5 times root 2. So it's 2 times root 5. My bad. that's going to be the square root of 4 times the square root of 5, which is 2 root 5. That's 2 root 5. Okay, and this length from there to there, because this is 10, is going to be 10 units. So I can find this angle over here. Now, how does this angle over here help us? Well, this angle actually is our answer. The tangent of this angle is the gradient of this line. Okay, so I mean, just in general, if you can understand that, that will help you here. That if you have a line, a straight line, okay, then the angle the line makes with the x-axis, okay, if you find the tangent of the angle, well, supposing this is the angle alpha, and you have this point and that point over here, well, the tangent of the angle will be the opposite, which is the change in y between these 2 points, over the adjacent, which is the change in x. So the gradient of this angle the gradient of this line is equal to the tangent of the angle, which is the change in y over the change in x, opposite over the adjacent. So if I can find what this angle is, then the tangent of the angle will give us the gradient. So I can find the angle because I have this right angle triangle. This side is the opposite, this side is the hypotenuse of this triangle that we have. So we can use the sine of theta is equal to the opposite, which is 2 root 5 over 10. 2 root 5 over 10, which is going to be root 5 over 5. Okay, so that's the sine of the angle. Okay, now if I can find the tangent of the angle, so now what I'm going to do is, I'm going to now redraw this triangle as a different triangle. I'm going to look at the triangle like this. Okay, so this is theta. Okay, now this length is now this is theta. I know that the sine of this angle, I can draw a triangle from this. I can make a right angle triangle where I know the sine of this angle is root 5 over 5. So opposite is root 5 and the hypotenuse is 5. So I can work out this side of the triangle. It's going to be the square root of 25 minus 5, which is the square root of 20. Okay, so this side of this particular triangle is going to be 2 root 5. So I can say that the tangent of the angle that I'm looking for is going to be opposite over the adjacent, which is root 5 over 2 root 5, which is basically 1 over 2. So the tangent of the angle is 1 over 2. So that means, as I said, the tangent of the angle is equal to 1 over 2. Therefore, the gradient of the line is also 1 over 2, which is what we found. And then we have another triangle, which is the same. And this is going to be a similar thing, but the gradient is going to be negative. So it's going to be the same situation over here. This is the right angle. This angle is the same as the angle, but the gradient of this line here is the same issue. It's just going to be like this way. So that's going to be root 5, and that's going to be 5. So we can say that the tangent of this angle is going to be, the gradient of this angle is going to be negative a half. So you're going to have m equals a half and m equals negative a half. So that's another way of working out the problem. We know that the gradient is equal to the tangent of the angle. Okay, so that's a bit of a shorter way of doing it, a visual type of way, and that works fine. So there we have two methods of answering part B. One is purely algebraic method involving the discriminant being equal to 0 when you have tangents to the circle, and the other one using basically some sort of like visual techniques and understanding that the gradient of a line is the same as the tangent of the angle that that line makes with the x-axis, with the horizontal. Okay, so there we have the answer to that question. Other questions from this particular paper can be found in the playlist that will appear in this area over here. Other questions from the topic of equations of circles from P1 of Cambridge can be found in the playlist over here. I'll also include a link to my material from P2 of EdXL, which has equations of circles in it there. There's quite a lot of questions from that. So that's been in that syllabus for a long time. You can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.